Another integral in disguise, we have the cotangent of x times the natural log of the sine of x dx. Initially we might try letting u equal sine of x, but that's going to give us a du of cosine x dx, and that is not what we have over here. But I do know something about taking derivatives of natural logs. And we're going to let u equal the natural log of the sine of x, so that when we take its derivative, u prime over u, derivative of sine of x is the cosine of x over u, sine of x dx. And I recognize this here to be the cotangent of x. So this is really nice for us. This becomes the integral of, here's my u right there, and then the rest, cotangent of x dx, is du. And so this is u squared over 2 plus c, and we re-substitute natural log of sine of x into our u, and that becomes the natural log of the sine of x squared over 2 plus c. Last integral in disguise is the integral of the tangent squared of 2x dx. Integral of tangent squared is not an integral formula that we know, but I do know something about tangent squared. I know that 1 plus the tangent squared is equal to the secant squared. And so I can replace tangent squared with the secant squared minus 1. Now it doesn't matter that it's 2x right there. Tangent squared of 2x will be secant squared of 2x minus 1. And so we'll rewrite this as secant squared 2x minus 1, and that is dx. And I like this very much because I do know who the integral of the secant squared is. The only thing is I'll need to use a little u substitution. But I'm going to rewrite first. Integral of secant squared of 2x dx minus the integral of 1 dx. Now we'll do u is equal to 2x. So du then is 2 dx. I don't have that, so I'll rewrite. Here's my 2. There's a half. And so this is 1/2 the integral of the secant squared of u du minus the integral of 1 dx. And so here I just have to think to myself, whose derivative do I take to get the secant squared? And I take the derivative of the tangent to get the secant squared. So this is 1/2 the tangent of u minus the integral of 1 dx is x. And then we have plus c. Resubstitute our u. Our u is 2x. And so this is 1/2 the tangent of 2x minus x plus c. And so that's basically a review. Last thing is just procedures for fitting integrands to basic rules. You know, one thing you can try is expanding the numerator. 1 plus e to the x squared is 1 plus 2 e to the x plus e to the 2x. Try separating the numerator, 1 plus x all over x squared plus 1 into 1 over x squared plus 1 plus x over x squared plus 1. You could try completing the square if you have a 2x minus an x squared, or an x to the first power minus an x squared. If that fits, try completing the square. You're going to get some arc trig functions sometimes. Divide improper rational fractions. Again, when your degrees of the top is greater than or equal to the degree of the bottom. Add and subtract terms in the numerator. Those were our integrals in disguise. And then finally, using some trigonometric identities. Here's another one for you that you need to remember. In addition to your 1 plus tangent squared is the secant squared, and of course your sine squared plus cosine squared is equal to 1.